Every example test you write is a guess, a specific input you thought to check. But the bug that bites you in production is almost always the input you didn't think of. Property-based testing flips the burden. Instead of picking examples, you state a property that should hold for every possible input, and the tool generates hundreds of random cases trying to break it. And when it finds a break, it hands you the simplest one. It's the perfect way to prove a value object is bulletproof. Let me show you. Here's the shift in thinking. An example test says, for this one input, I expect this one output. It's only ever as good as the handful of cases you remembered to write. A property test asks a different question. Is there a rule that should hold for every input? Then it generates hundreds of random inputs. Empty strings, gigantic strings, Unicode, negative numbers, and tries to find one that breaks your rule. And the killer feature, when it does find a failure, it doesn't dump a random mess on you. It shrinks that failure down to the simplest possible counterexample and gives you a seed to reproduce it exactly. You go from something's wrong somewhere to this exact tiny input breaks it. Let's prove the most important property of a value object, totality. A factory like try-create should be a total function, defined for every possible input, returning a result and never, ever throwing. We bring in CsCheck, a third-party library, not part of Trellis, and we write one property. Generate any string at all, call try-create, and simply return true. The point is the call itself. CsCheck throws hundreds of empty, white space, Unicode, and enormous strings at it, and if a single one caused an exception, the test fails. Pass this, and you've proven something an example test never could, that there is no string in the universe that makes this factory blow up. Now two sharper properties. The first pins the boundary exactly. Across random strings from 0 to 250 characters, try-create should succeed precisely when the length is between 1 and 200 and fail everywhere else. One line, and CsCheck hammers both sides of that boundary so you don't have to write the off-by-one test by hand. The second is a round trip. Any valid title, run through try-create and back out as a value, should come back exactly as it went in, nothing silently mangled or truncated. These two properties, checked over hundreds of cases each, lock down the entire contract of the type. And here's the payoff in action. Suppose your length rule had a bug. A naive random test might fail on some 4,000 character monster string, useless for debugging. CsCheck shrinks instead. It takes whatever random input broke the property and reduces it, step by step, to the simplest input that still fails. Here, a string of exactly 201 characters, the precise boundary, and it gives you a seed to replay that exact case forever. That's the difference. You're not handed a haystack, you're handed the needle. This is why property-based testing is so good at the base of the pyramid. It turns "I hope I covered the edges" into proof. So when do you reach for property-based testing? 3 sweet spots. Totality. Any factory or parser that must never throw, no matter what input arrives. Exactly our value objects. Round trips and inverses. Anything you encode and decode or serialize and deserialize should come back as the original. A property that catches a whole class of subtle bugs. And invariance. A rule that must hold for every value. A length bound. An ordering. A conserved total. An operation that's safe to repeat. You still write example tests for the specific cases you care about. But for these, you let the computer generate the cases and shrink its way to the one that matters. That's property-based testing. Instead of guessing inputs, you state a rule that must always hold, and let the tool generate hundreds of cases and shrink any failure to the simplest one. For value objects, it's a perfect fit. You prove totality, boundaries, and round trips in a few lines, with confidence no list of hand-picked examples could match. Next time, we move up from single values to whole aggregates, testing invariance and the domain events they raise. Subscribe, and I'll see you there.